It's great to see you.
Thanks. Great. So yesterday I was walking around Camden, and I had this idea that I would go to the hardware store. By the way, this is a really bad idea, and I had enough sense not to follow through with it. But go to the hardware store, buy some pulleys and some nuts and bolts and a few pieces of 2x4s, and bolt the pulleys, to the 2x4, and then strap the 2x4s to my feet. So while I was giving the presentation, I could just kind of glide around. There's a couple of bad ideas there. One is I don't know how to roller skate, and two, there's a rug up here, and rugs and the friction and pulleys are probably mechanically not so great. I'm from Berkeley, California, and let's see if, and I've been making things that moved in one form or another for as long as I can remember. This is a pair of stilts made out of 2x2s and 2x4s, and made out of wood. I love wood. And in high school, I really loved all kinds of math, but particularly constructions, and particularly what you can make with a straight edge and a compass, and all the wonderful sort of shapes, and also just the hands-on aspect of that kind of math. And I went to college and started studying math, and then changed majors to geology because I wanted to go camping. And then I changed majors again to anthropology because I wanted to go traveling. And then my senior year, I changed majors again and graduated in English because I wanted to be a poet, which was for me, one of the worst ideas I ever tried. And I set off after college with this typewriter strapped to the back of my motorcycle. And I had an idea that if every stop I wrote a poem, by the time I got cross country, I'd have my first book of poetry. So I stopped shortly out of town for gas, and there's a picnic table, and put some paper in the machine and sat down, and I maybe decided that every other stop might be a little bit of a better strategy. I became every third stop, and pretty soon, I was all the way back to California, and I was like, all right, this is not working so well. So I thought, well, what I need is a table to write on, and if this table, instead of having table legs, what if it had wheels, and also a motor, and I could drive it around the country having conversations about utopia and the meaning of life. So I built this. This is the Traveling Commons, and it's got a sort of a cut down and welded together VW chassis. And I loaded it up with 2 typewriters and no spare tire. And the middle part of it folded down to make a flat tabletop. And this is the view looking backwards. It wasn't a really great trip. I lasted about 5 months. I did not make it around the world. I made it to sort of the middle of Texas. And it was a very big state, so I did well. But it was really hot. Like all the sun, would bounce off the whole perimeter of the table. And I was quite happy to get off of it. In 1994, I got very interested in this caterpillar that I saw. And while I talk about the caterpillar, I'd like to bring up this sculpture over here, please. And if anyone's debating right now between sculpture and painting, you're going to see why painting is a little bit easier. And sculpture has these logistical, things. Anyway, so the caterpillar that I saw in '94. I saw it in Utah, and believe it or not, it was transparent, and I could see how it moved. And I decided I was going to make a mechanical version of it. And the first thing I did is spend 2 months working on the math. And I got the math completely upside down and backwards, and eventually I got it right. But for the first caterpillar, I didn't. And so I worked on the math, and then I decided I needed some motors, and got Ford Escort windshield wiper motors, and kind of, jerry-rigged everything together, and made a switch using lots of pieces of tape measure, and made the caterpillar, and gave the final performance for it. Hey, that's awesome. Cool. Right on. Thanks. Gave a final performance of it, and this is a video of the caterpillar. It's very short. Now, you don't have to say anything because it's kind of disappointing, right? I mean, I was kind of hoping for a totally fluid, you know, what I had in my mind was this totally thing. And in 17 minutes, it went, 2 feet, and it was just a complete mess. So at about that time, I had an artist residency in Spain. And I was thinking, about still making a caterpillar, and I was also spending a lot of time outside. And occasionally, and it doesn't happen as often as I wish it did, but occasionally the world is just incredibly beautiful. And it's just, and sometimes the light is just right, and there's just some sort of movement, and you're in it, and it's just the miracle that we're, we're alive, and we're on Earth, and there's all these things we don't understand, and the trees are moving, and it's just so wonderful. And there's a sort of buoyancy and lightness that I really wanted. And the caterpillar, despite the fact it didn't really work, was also just a little bit too jointed and too sort of robotic. And there was something else I was trying to go for. And part of the problem with the caterpillar is that it's a sine wave, but it's sort of cut in half by the ground. And I kept thinking if it could go through the ground, it'd be a lot easier to make. So this right here it's a circle, and it's got a bunch of strings. And the strings go, to various sections. And right now, all the strings are tied in a knot, and they're right in the center of the circle. And if you move them to one side, you get a wave. And if you roll around, you get a sine wave. Now, there's a couple different languages we can talk about this with. One is that the wave has an amplitude, right? And the amplitude is just the distance between the peak and the valley. In other words, it has a frequency, and the frequency is how fast the wave is moving. And another one is that it has a wavelength, and the wavelength is the distance between, where it starts to repeat again. If you, repeated it on, you keep going with this wave until we got to Canada. Another way to talk about it is that, and I probably think more about it this sense, is that it has a high point, and it has a low point. And maybe most importantly, it can always be moving. It can always be changing, and yet it's always kind of the same. And it's that sort of thing. I mean, what is it? What else in life has highs and lows and is always changing, but is always the same? Or what isn't? Everything is kind of like that. And we see waves absolutely everywhere. We see them in water, we see them in wind, and because it's based on a circle, we see them in anything that cycles. And so things like the Earth going around the sun, the seasons, the moon going around the Earth, the tides, all these are expressed as waves. So I ended up back in California, and this is called the square wave. And up overhead, there's 2 camshafts that work, in effect, similar to this principle. There's an array of pulleys overhead, and this is made out of 144, pieces of wood. And this is a plane wave, so if you took that wave and you extended it into a plane, this is what you would get. And now, if you add a wave that's perpendicular to it, start to get this is about 10 feet by 10 feet, and it's super low tech. It's quite similar to this in construction. There's more pulleys, there's a couple more motors, but there's no computer, there's nothing digital about it. Let me show you another one. This is the round wave. Similar idea, mechanics above, rings below. And right here, it's beginning at a 0 amplitude, so as if this point were in the center. And now it's just this was inspired by a drop of water, the way, like a drop of rain would hit water, and just these circles that kind of flow outwards. And so I'm often inspired by, just by taking a walk in nature. And one time I was on a rafting trip, and we were, paddling, and your paddle goes through the water. And have you ever seen that swirl that comes off of the back of the paddle? That sort of eddy? was on the Green River, and it was a really slow trip. And so I got sort of, I just had a lot of time to like look at those swirls and that pattern, think about how I was going to make it. And so how would it look if you made a pattern like that? And let's just say that you made the top part out of aluminum arms, and let's say you made the bottom part out of, reflective faceted beads, like a lot of them, like 12,000. What would that look like? And I'd like to show you. So this has so this is slowly descending. So it'll come down for not much lower, but you'll get a slightly better view of it. It has 241 strings, Dacron strings, and about 12,000 beads that are on little bits of stainless wire that are all articulated. It has 3 motors, one just controls the sort of all the up and down, and one of them the wave that's moving around it, and one of them the rotation. And I mean, there's just a huge thanks to, thanks for PopTech for making this piece happen, and a huge thanks to the Opera House for working with me trying to figure out how to get it up the stairs and installed. You're all awesome. Cool, thanks. So, this is one of the great secrets of making something that has lots of small parts is the work party. And so it's a little bit of, you get a big pot of chili and some beers, and you call up all your friends, and it's amazing how many little beads you can get strung in a day. And so big thanks to those folks. This is a wave that's right now in Technorama, Switzerland. What I think I'd like to do is let me show you another quick video of another piece. Those are all pulleys, and this is a piece that's in my shop that has some variacs for controlling the speed. And those are all dowels, and this one's based actually on 2 different raindrops, that sort of intersection of that pattern. This one, and this, the structure above is extremely similar. It's got a bunch of strings going to one place, and then they'll go down to these cardboard tubes. And it makes a 5-pointed sort of star, so it's called the pentagonal wave. So I never went to art school, but I did go to a painting school. I went to 2 painting schools. One of them was in Italy, and it's called the Charles Cecil Studios. And we studied portrait painting. And this is a painting I did there, and it's oil. And the sense of reality at this school was the sense of light. And if you managed to capture the sense of light right, then you had gotten it. And the way that this technique works, if I was going to paint your portrait, you would sit right here in a chair, and I would have a canvas right here, and I would stand back, and I would just transfer visually all of the information over, and you could stand back and sort of squint and blur your eyes and see if you got it right or not. And it was a way of separating the visual world from everything else that we know about the world. And then I got an opportunity to study in the St. Petersburg Academy of Russia. And I went there in January and was just like terrified about freezing. And so I put my long underwear on before I got on the airplane. And the airplane was really hot. By the time I got off the airplane, I was just drenched with sweat. It did freeze practically to death. And I went to this a studio there called Masтерская Monumental. And this is it was in a large room, and maybe twice as big as the stage, and there's 3 big podiums with male models and underwear and bare light bulbs above them, and there's maybe 20 students in this program who are just incredible draftsmen. And so I start drawing, and I'm drawing this is sepia on paper, and I have a planchette, which is a way of taking paper and gluing it to a board. And I started drawing, and I started doing what I've been doing in Italy, which is massing in the shadows and working on it. And the instructor is coming around, and he's giving critiques. And he comes to me, and he just starts yelling at me in Russian. Just yelling. And I'd been trying to learn Russian. I had the Berlitz language tapes, but I didn't know what he was saying. And so another student translated. And the translation was, either you're a coward or there's something wrong with your soul if you're drawing like that. I remember kind of thinking that, I want to be back in California. I don't know about this. But there I was, and I was like, okay, well, bring it on. I'm here, what's going on? And he said, either you're a coward or there's something wrong with your soul if you're drawing like that because you're drawing what you see. Okay. Okay, what? And he's like, you can't draw what you see. You can't just copy what you see. You have to construct the figure. You have to draw it from what you know to be true about it. You have to draw the volume of it. You have to draw the mass of it. And he took my easel, and he put it, here's the podium, here's the model. Put my easel right there, right next to him. And he said, now draw, and make that drawing look as heavy as he is. So there's two different ways to approach art, and they're both true. And one of them is that the world is a beautiful place, and it's full of highlights, and it's full of sparkles, and it's full of, kind of dawns and dusks and mystery and beauty. And the other one is that it has a structure behind it. And is this structure behind it, is it mathematical? Does it have to do with sine waves and waves? I don't know. Some does, and to me the difference between the two ways of sort of looking at the world is sort of the difference between whether you are reaching out to touch the world or whether you're letting the world touch you. And in a way that the visual, the sort of beauty, the mystery is a way where you're kind of sitting back and the world is touching you. And that when you're looking for the structure, you're sort of throwing your net out onto the world to see if it fits mathematically. And so, I guess I would like to close with that that both the structure and the beauty are something that we can gather together and try to use to make works of art. Thank you.